So data. So we are living with the data, correct or not? Yes. Okay. So day-to-day activities, in our day-to-day activities, knowingly or unknowingly, we are generating the data. Okay. Shiva, can you give us some example how we are generating the data? Yes, boss. Morning you're waking up. First, what is that first activity you do? First, you will see the WhatsApp messages. Any messages we got in last night? Okay. If you give a reply in WhatsApp, that is not data generation. That is not a data generation. If your friend sends some messages to your WhatsApp, that is not data generation. And you are forwarding some images to some groups, that is not a data generation. Yes. Okay. Not only that one, guys. I'm just giving an example here, and after that, you'll like you'll go and switch on the TV after waking up. Then that is also data generation on indirectly. So like you'll go and like open the Facebook or Twitter. What's going on? You wanted to learn actually. You wanted to understand actually. Then Twitter messages also data generation part comes under data generation. So what I'm trying to say is indirectly or directly, even if I'm talking in Zoom, this is also data generation, right? Data processing, right? Indirectly, I'm forwarding the meeting link, and like Zoom people are capturing how many hours I'm trying to capture, how many hours I'm teaching, and back end they have to switch off if I'm trying to like take the classes for more than 4 hours. So that is also data generation only. But I don't know that back end I'm generating the data. Okay, still many examples are there. I'm just trying to like tell you at a high level. These are all data generation activities. Okay, Shiva, that is okay. Like, what do we do with this data? Everywhere data is there. Everywhere. Okay, what do we do with this data? We have to build data analytics on top of that. We have to build analytics on top of that. We have to do analysis on top of your data. Now, so what is the use of this analysis? Let's say, let's say you're talking in a phone. Okay, you'll recharge for every 3 months, and they'll give 1 GB of data to you every day, and they'll sometimes they'll send promotion codes and all. So do you think all data providers, all data generator guys, like let's say Facebook, sorry, not Facebook, I can say, like what are all the applications you guys are using in your mobile phone? All those guys are actually capturing your data in the backend. Do you agree with that? You guys don't know actually, they're capturing your secrets.
Recording in progress.
One minute. Okay. Like all data application guys actually, like what are all the applications you guys are using in your mobile phone? Mobile phone. Okay. Those applications, those apps actually capturing your data in the backend. What do they do with that data? You take any application, guys. You take Airtel app or Facebook app or Twitter app or like Amazon app, what not, everything, even YouTube also. When you try to search something in the YouTube, after some time, if you open that YouTube again, you're getting you'll get some suggestions or not. How you're going to get that suggestions? How you're going to get that suggestions? YouTube is capturing your data in the back end, and they're running some algorithms in the back end, and they're giving suggestions, and they do promotions on top of that. Right side, okay. Let's say, for example, let's say you're trying to search something in the Amazon. Let's say I wanted to buy a phone. Okay, you have done some research on that one. Okay, which phone to buy? You have done some research. Finally, you haven't decided anything, and you close the app. And after some time, you try to open the YouTube. Right side, 100%, you will get some phone related promotions. What is that actually? What is that? That is nothing but your data analysis. See, have you ever think of these things? You guys keep on creating the Facebook accounts, right? You guys are keep on creating the Facebook account or Twitter account, right? Of course, Twitter started like charging recently, but previously it was free of cost, right? You guys are not paying anything to them, but how come the CEO of the company or the founder of the company became one of the millionaire in the world? Have you ever think about that? How come he became a billionaire, one of the richest man in the world? How come he became a millionaire?
పడుకోవాలి తొందరగా వచ్చిన
Okay. How come he became a billionaire actually? You know what they are doing, you know? They are doing business with your data. They're selling your data in the back end. But officially, they don't announce that they're doing the business. Lakhs of users are subscribing. Lakhs of users are creating the account. How come the revenue is getting generated? Ultimately, they have to process the data and they have to do some analysis, and they're living with the promotions. They have to process the data and they have to do some promotions. Like how you're getting right side in YouTube, that suggestions. Hey, this phone is good and this phone has so and so feature. How you're getting that one? In the same way, they have to send the promotions. Okay, let me tell you one more example here. Airtel, sometimes they used to send these messages, right? Okay, only for you. Okay, like you might have seen these kind of messages in the Airtel. So save 30% on, okay, if you recharge today, we'll give 30% discount. Or we'll give, instead of 1 GB data every day, we'll give 1.5 GB data. Hey, why is giving only to you? How come he know that? How come he know that you have to recharge so and so day? How come he know that? How come he's suggesting that you have to take 1.5 GB every day? How come he's suggesting actually, hey, you have to recharge with so and so amount so that you'll get the so and so activities? How come he's understanding all those things? They're actually finding out the patterns. They're doing the business with that. They're using that data whenever you recharge, right? That is a transaction from Airtel side. And you're using like 1 GB every day. 1 GB every day. And they capture that information in the backend. That is also a data. Indirectly, you're generating a data for Airtel. And they'll next month onward, they'll promote that 1 GB is not enough for you. You're using like more data every day for day-to-day activities. Now you try to recharge with 1.5 GB. How come he's suggesting to us? Why is giving only offer only for you? The Airtel CEO is my relative. He's my brother. No, how come he's suggesting to you then? They're making business out of it, man. They're simply making business. My sincere suggestion to you guys is, any app asking you to give the access for the contacts or images, right? Don't give that. Facebook is simply an app. It's an application. That's it. Why does it need our contacts actually? Why does it need it need contact or contacts access? Why does it need our images access? They're stealing your data indirectly. They're processing the data. They're making a business out of it. They're doing a business out of it, and they're making money out of it. Okay. Okay. A simple fruit seller actually, let's say he is selling apples, oranges, and dragon fruits like that. He's selling everyday fruits. How does he come to know? How does he come to know at the end of the day how much profit he got, how much loss he got, how many apples are rotten, how many apples he sold today, how many oranges he sold today, how many customers visited his shop? How does he come to know? Let's say a small vendor means obviously he will note down everything in a notebook, or uh, or he will remember like a few transactions. Transactions means like customers. See, for small shopkeeper, that is okay. He don't need to have that kind of analysis. But what if it is a Walmart or Costco or like DMart, like big big shots? How much data they are generating? How many people are visiting Costco every day? How many people are visiting DMart every day? How many stores are there? Thousands of stores are there across the world. Walmart has thousands of stores across the world. How many people are visiting? How many uh, like items are how many items are purchased by the customer? They have to capture all those things, right? So indirectly those guys are actually generating the data. Not only DMart guys, DMart or Walmart or Costco guys, even Amazon people are also every day. How many people are purchasing the products from the Amazon? How many people are ordering the products from the Amazon? And what if it is a great Indian festival or Big Billion Days in Flipkart? How many people are purchasing the products? How much data is getting generated here? So if you do credit card transaction or a debit card transaction, indirectly those transactions has to be captured by your Visa or Fico or like whoever is providing that card. They have to capture all the transactions, right? That is also a data. See, what I'm trying to say is how we are generating the data knowingly or unknowingly for in a day-to-day life. That's what I'm trying to say here. When you go to like Walmart, indirectly you're generating the data there. Okay, so Siva has purchased so and so items today. On his items, we have given this much of discount. All those things are data only. Back and they have to store the data in a database. Okay, not only these guys actually every day 1 million GB of data is processed by Google. Guys, this is not a latest statistics I'm talking here. Almost 6-7 years back, these statistics, from the internet, I've taken these statistics. So 30 billion pieces of content shared by Facebook every month. 30 billion. It would have crossed more than 100 times by this time. Like, see what happened, like all these big shot companies actually started generating the huge volume of data. That's what I wanted to say here. What they have to do with this data now? They have to, I told you already. They have to do analysis on top of that. Now, can you like consider one scenario here? Let's consider Google is trying to process actually 20 million GB of file. 20 million GB of file. Is it so easy to process 20 million GB file every day? 20. Let's consider Google is trying to generate that file. Of course, nowadays it is they are generating more than that size. So in order to do that analysis, they have to process the data, right? They have to take out the junk data out of it, right? They have to do some. They have to build some insights out of it, right? Now, how do you process this much volume of data? Does your system supports really? No. Every day, if you want to process this much of data, it's very difficult. It's very difficult. Now, see, 4 or 5 years back, Google has announced that if you want, you can go and check the all these statistics in Google. Google started generating 20 petabytes of data. PB is nothing but a petabytes. Petabytes of data every day. Okay. Google processes 20 petabytes of data, or Facebook generates 2.5 petabytes of users' data per month, I can say, or 15 TB per day in 2009, in the year of 2009. In 2009, eBay was generating 6.5 petabytes of data. See, like my ultimate goal is why the big data came into the market. Eventually, I'll go and land there. See, in 2008 and in the 2008 and 2009, from 2000 later 2005, these big shots actually generating the huge volume of data. Okay. Now, at that time, Shiva, we have databases, right? We have Oracle database was there, like SQL Server database was there, and even IBM DB2 was there, and like your Teradata was there. All those guys were there, right? They were actually processing the data, right? Then what is the problem? They were there in the market, of course. Guys, remember one thing. Even your Oracle or SQL Server or IBM DB2 or Teradata, whatever the database it is, you take any MySQL or whatever you take, Postgres, what not, you take any database. All those traditional databases, they are good up to 200 terabytes of data. But actually, Google is generating petabytes of data, not terabytes. Now, who has to process the data in that case? Petabytes is a bigger number or terabytes is a bigger number? Petabytes is the bigger number. But they're good up to 200 TB of data. That's it. They can process maximum up to, I mean, up to means less than 200 TB only. If you try to process more than 200 TB, your database will literally cry, or it will die. Anything will happen. Okay. In internet, actually, for every minute actually, these many number of transactions are happening in every minute. In every minute, I took all these things from Google only. See, these statistics, I'm still telling 5 years back statistics. Think about the data that these people are generating in the internet. Okay. Now, what is big data in that case? Huge volume of data. Can you say big data? No, I cannot say like that. There is no definition for the big data. I cannot say that huge volume of data is nothing but a big data. Okay. Huh. Okay. Big data is nothing but actually, there is no standard definition, I can say. What I would say is, but we have to process that big data, like to do that analytics, analytics, of course, to survive in the market. Facebook has to process their data to survive in the market. Otherwise, they cannot make the revenue out of it. They cannot make the revenue out of the data that they have. Okay, and that too, guys. Like once the internet has become very popular in the market, right? Okay, then internet has started generating huge volume of data. Previously, before the internet has become famous in the market, okay, uh, we used to have only structured data, and that too, your traditional databases, MySQL, Oracle, SQL Server, Teradata, like all those things actually, all those people actually, they used to process only structured data. They used to process only structured data. Can Oracle process semi-structured data? Can Oracle process unstructured data? Because of the advancement in the software, at that time software was booming like anyway. Because of the advancement of this advancement in the software, like people started building in applications. People started building applications in Java, .NET, or C Sharp. Any of the they're using all these languages that they started building the applications. Now, whenever the like applications started talking each other, when two applications are integrated, they started generating the data in the form of like XML or JSON. Two applications talk can talk with the files called JSON and XML. You guys know all the web applications actually generates the data either in JSON or XML format. Now JSON data, XML data also has become very popular after 2010. Before it was there before, but that was not that much popular. But it people started like applications started like generating JSON and XML data, and we have to process that data as well. You know, Amazon, they don't store the data in a structured format. They store the data in JSON format, the customer data, product data, order data, what not, everything they store that data in a JSON format. Now, people started using these file formats. Now, traditional databases does not have capability to process, to read the data from those files, to process the data from those files. And that too, how do we process that much volume of data? What kind of data we have in the market? Social media data is there. Like what they can do with that big data? They can do they can promote they can promote certain brand. They can do the product sentimental analysis. Let's say one movie is released or one iPhone like brand is released. They wanted to find out actually people minds. They wanted to like see how people are reacting to that product. Let's say iPhone 16 released. People started posting everything in a X or Twitter. Now Twitter will collect all this data and they'll try to build some analytics out of it, and they will try to sell that data to the like Apple people. Hey, iPhone 16. Actually, this is the response from the people. People liked it much, or people are not satisfied with your product. And like, if they're not satisfied, what is the reason for that? These are all the features they don't like it actually. So that kind of sentimental analysis they can do. Now Twitter is actually selling that data to the Apple. Otherwise, how Apple come to know that? Okay, their the product analysis. How come they'll come to know? Back end, they'll purchase this data actually. Okay, even credit card companies actually, if you try to do like a huge volume of transactions, right? They'll try to like detect. They'll try to identify the fraudulent transactions with that huge volume of data. So they can do anything here. They can build like algorithms out of it, and they can do some predictive analytics on top of it. They have to process this data actually. They have to process this big data. Now to all these, okay, so traditional databases actually does not have capability to process all this data. Then what is the solution for that? So what's the solution for that? I know that if I start doing analysis, actually, it is going to give like it is going to generate some revenue for me. With that data, I can build some insights. But it's very difficult to process that data. That to traditional databases are good up to 200 TB of data. That's it. Now people started thinking at that time. Okay. At that time, our hero came into the market. Who is that hero now? Who is that hero? Hadoop. Hadoop came into the market at that time. Okay. I'll tell you the years also. I have one like a slide actually to talk about that one. So it came into the market in 2011 actually. Hadoop came into the market in 2011. Till 2011, there was no application or there was no system to process this much volume of data in the market. Google also was struggling a lot. Facebook also struggling a lot. Amazon also struggling a lot. eBay also struggling a lot to process their data. Because day by day, the number of transactions are increasing like anyway. Okay, at that time, our hero came into the market. So that guy is actually Hadoop. Okay. Now, what is the strategy that they have used here, like to process that huge volume of data? I'm trying to explain here, like concept of the Hadoop that they have used in the early stages. Okay, what they'll do is, okay, one more thing I wanted to tell you guys here. Till Hadoop came into the market, I told you people used to use Oracle, SQL Server, Teradata, your IBM DB2 or MySQL, Postgres. They used to use all those databases, right? Now, have you ever like seen, have you ever installed those like databases? Generally, what do? We have to install Oracle database or SQL Server database only in one database, right? Only in one system, right? Only in one system, right? Or in multiple systems. I mean, multiple systems, we like install that and we connect all those things. Generally, even in even if you go and see your OLAP systems in your companies, actually, they'll try to install all these databases only in one system. Okay. That too, not a system. I can say it is a server. Server is nothing but with high configuration. It is also a system with high configuration. With high configuration. They used to install all these systems actually, all these softwares actually in a server. So those servers, we call it as a monolithic systems. Monolithic systems. Okay. If you want to process your terabytes of data, this system has to process that data. Now, single system cannot able to process that much volume of data. If consider Google is generating 20 petabytes of data every day, or Facebook is generating 20 petabytes of data every day, does your system has that much of storage to process, first of all, to process it? See, before you process, you have to store it, right? Does your system has the capabilities to store that much volume of data? No. First of all, no. Okay. Now, how Hadoop came into the market and resolved that issue is, and that too, to process this data, it will take days, not hours. To process 1 day of data, it may take 1 week also for that, for the system. It may take month also to process that data. For only processing one day worth of data, if it is taking 1 month, then it doesn't make any sense, right? So what Hadoop said when it came to the market, hey, we don't process the data as is whatever you're giving, like how traditional databases are actually doing. What we will do is, let's say, if you have 100, let's say if you have 1 GB of data, if you want to process 1 GB of data, we will try to divide that data into small pieces. Let's say, I'll try to divide this 1 GB of data into 128 MB of data blocks. Not physically. Logically, I'll try to divide this data into 128 MB block. Guys, remember this number. This will be useful even in interviews also. Okay, sometimes they'll ask you what is the default block size in Hadoop 1.0, 128 MB. Okay, what they will do is, if you have 1 GB of data, they don't process that 1 GB of data directly. They'll try to divide that into 128 MB blocks logically, and they'll try to process the data parallelly. Now, in order to do that process parallelly, so after dividing that one, in order to process this block, actually, you have one system here, and in order to process this data, this block, actually, you have one more system here, and in order to process this data, you have one more system here, and you have one more system here. Like that, you will take the systems you'll take the cluster of systems here, or you will consider a cluster here. That cluster you will use to process your data, not the single system. You're going to use the group of systems to process your data parallelly. That is the concept of Hadoop now. At that time. Are you guys with me? Able to get it?
Yes.
Okay. Huh. So what I'm trying to say is, in Hadoop, actually, you will be having group of systems to process your data. That's what I wanted to say here. We don't have single system concept here. We have like group of systems which processes your data, actually. That is the beauty. So that what will happen? They can process the data quickly, right? Even 20 petabytes of data, let's say, I have to process 1 GB of data. I'm taking 4 systems in my cluster. Tomorrow, if my data, volume of data is increasing because of the number of customers are increasing, what I will do is I'll try to go ahead and add one more system to my cluster. So that whatever the additional like data got increased, right? My additional system, whatever I added in the cluster, right? That will take care of this, the additional data. And if the data is keep on increasing, I'll keep on increase the cluster size here. I can increase the cluster size. Like I can increase any number of systems here. I can add any number of systems in a cluster here to process my data. 10 systems, 100 systems, 500 systems, 10,000 systems also you can use. No problem. At that time in 2009 or 2008, 2009, 2010, the system hardware cost was very cheap, I can say. At that time, like slowly the computer or laptop cost started decreasing in after 2008, I think. I mean, what I mean to say here is slowly, year by year, the hardware has become very cheap. Hardware is available very cheap. See, before 2008, okay, we used to have actually in 2006 or 7, we used to have dual core systems, right? Dual core system, they used to, like, it used to cost almost 30,000 rupees in the market. Okay, after that, P4 systems came into the market. Before that, Pentium 4, after that, dual core systems, and after that, i3 systems came into the market, and after that, i5 systems came into the market. I mean, processors I'm talking here. So at that time, when we were using actually P4 systems or dual core systems, 1 GB RAM, 2 GB RAM, if you use, right, it's very huge at that point of time. Now, even if you nowadays, if you use even 32 GB RAM, 32 GB of RAM, people are saying that only 32 GB. I need 64 GB of RAM in my laptop. That's what the expectation. At that time in 2000, early 2000s actually, like after 2005, people used to use 1 GB RAM, 2 GB RAMs only. Hardly high configuration systems, they use actually 4 GB RAMs at that time. Because the hardware was very costly to use that 8 GB RAMs or 16 GB RAMs. Slowly in the market, actually, this hardware, the cost of the hardware has become cheap. So I can go ahead and add any number of systems to my cluster so that I can process the data very quickly. That is what their motto here, Hadoop motto here. Hardware is anyway cheap. You try to add any number of systems to the cluster and process it. That's what they're trying to say here. Divide the overall problem into small tasks. Overall problem is big data. Actually, they're trying to divide it into 120 MB block or 254 MB, 256 MB of blocks. And they're trying to process it parallelly, that too. Okay. That is okay. That is okay. Shiva, if you try to process it parallelly, what will happen? Let's say monolithic system actually, nothing but one single mission actually. It has 4 input output channels, and each channel can process, let's say, 100 MB per second. Like that, it has 4 input output channels. Consider, okay. Let's consider it can process the data, your 1 TB of data in 43 minutes. If I take the Hadoop concept here, if I take 10 missions here in my cluster, and if I try to process 1 TB of data, how much time it is going to take here? the same configuration, whatever we have here, how much it is, how much time it is going to take? If 10 systems are processing parallelly, how much it is going to take? How long it is going to take? Hardly it will take 4.3 minutes. That's it. That is the advantage of Hadoop systems. Okay. This is what I was telling actually. So in Hadoop 1.0, 64 MB was the default block size actually. In Hadoop 2.0, 128 MB is the default block size. When you try to process 1 GB of data, they'll try to divide your data into 128 MB blocks and they'll try to process it parallelly. Even Spark also follows the same thing, guys. Spark also follows the same thing. Okay. Okay. Now, what was the actual problem we have before Hadoop? What was the problem actually?
Processing time.
Processing data. Okay. Yeah. So our traditional systems actually they were not able to handle huge volume of data. So for that, what is that solution we got here actually? Big data. That is Hadoop came into the market and they started processing everything in a. They introduced actually parallel processing. Now the time got reduced. Processing time got reduced. That is okay, Shiva. Processing time got reduced. Now, how do I process the data? Which language I have to use to process that data? What is that framework actually? Hadoop, they used to use actually when they came into the market, actually, they used to use MapReduce is the programming language they used to use. I mean, MapReduce framework they used to use. MapReduce is one of the framework. They used to use that framework to process your data. You know, this MapReduce framework, okay, like in order to process your data, you have to write your code in Java language. In order to give the input to the Hadoop, actually, you have to write Java language. MapReduce is built on top of Java. Now you have to write Java language like to process your data. Not everyone knows Java, right? You know, like in 2000, I don't remember the exact year. In 2014 time, I still remember one of my colleague actually, he took training in Amirpet on Hadoop actually, and he joined in some company. I came to know that he joined in some organization. He got very good package. Okay. One day I called him. Hey, his name is Banu. His name is Banu. Still I remember his name. Okay. His name is Banu. Hey Banu, like even I wanted to learn Hadoop. I wanted to get into the IT market. So how is Hadoop market actually? Just let me know. I'll also learn. And where did you learn all these Hadoop course? I'll also go there and I'll try to take the training from them. That's what I asked him actually. You know what did he say? Hey, Hadoop is very tough. It's very difficult to learn. You have to have the knowledge in Java because you have to write MapReduce programs to process our data. Don't come into Hadoop. Don't join this course. That's what the statement that he has made at that time. Do you think MapReduce programming is so easy? No, not at all. Why I'm telling that point is, I'll tell you here. I have a slide deck for that. So what is the concept behind this MapReduce programming? You know what they will do? They'll try to read your data, they'll whatever the data that you want to process, right? They'll try to read this data and they'll try to divide that into blocks, input split 1, 2, 3, 4, and so on. Like 1 GB data means 1 GB is nothing but 1024 MB. 1024 divided by 128 MB. How many blocks you're going to get? That many number of blocks they'll try to divide it. And to accept this data, you have to write mapper program. You have to write mapper program. This is also a Java program again. This is also a Java program again. Okay. Now, after processing this data, you have to combine the results of this output of this mapper program, right? For that, again, you have to write combiner program. This is also a Java code again. Okay. And after combining this data, you have to shuffle the data sometimes. Shuffling means, like, let's say if you want to join the data, right? Let's say customer one data we have here, customer one, and customer one data, same data we also have here. And you have to bring them to one place and you have to shuffle the data between the nodes. And for that, again, you have to write the shuffle and sorting code. All these things you have to write in a Java language again. And finally, you have to write the reducer code. And finally, you have to capture that data into like one mission in HDFS. So all these process actually done by your MapReduce programming. Okay, simple example I'll tell you. I have one beautiful diagram here. Simple words actually. This is the one. Okay, let me try to arrange this up. Just a second. Now, what I'm trying to say is, if at all if you want to make a burger or hot dog or a pizza, generally we use all this raw material, right? Okay. Now, this is your raw data. If you want to get your final output, actually, what you have to do with all these items, you have to cut these items into slices, right? First, indirectly, your mapper program is going to do that one. Mapper has to split that data and it has to prepare nicely here. And wherever you want, you cook these items. Wherever you want, you do some activity here. And finally, you prepare your item. Same way, MapReduce programming also does in the backend. You have to cut the data into like smaller pieces. I mean, cutting means not physically, guys, here. I'm not supposed to use the word cut here. I'm dividing the data into smaller pieces, I can say. Logically. I know cut is a not right word here. Okay, you have to use the reducer program to reduce that and finally make some insights out of it. This is the best example to understand the MapReduce programming. And that too, guys, what happened, Java is a very difficult language, first of all. Okay, of course, people who worked on Java language, they don't accept this one, I know. Okay, generally people think that, okay, programming languages are very difficult. To process this data, to process this data actually in the market, we have actually SQL language. And all those SQL people actually, they have to learn Java now to process this data because of this Hadoop. There is no option. There is no other option. There is no other option for them. You have to learn Java and you have to write the coding. Okay. Okay. MapReduce was the solution to process the data. Okay. So you guys understood now. The problem of these monolithic system was actually monolithic systems doesn't have capability to process the huge volume of data. That problem is actually overcome by Hadoop distribution system. And in order to process that data, SQL is not the language. MapReduce is the language to process your data. Yes, we got the solution now. Okay, MapReduce. Okay, in the market actually, people started using MapReduce. That's okay. Consider for some time. People started using MapReducing. Okay, now I got the solution as well here. MapReduce programming is the best option to process your data. That is okay, Siva. But you're processing this much volume of data, right? Where do you store the data? Where do you store the data? For that, actually, again, Hadoop has given solution that is HDFS. What they are trying to say here is HDFS full form is Hadoop distributed file system. What they are trying to say is, hey, we are trying to use here all these systems parallelly like this. Okay, let's consider this. Let's consider this hardware or this system is having 4 TB of hard disk. They'll try to store the data in the distributed system in the hard disk of the systems actually. In this distributed system, all these distributed systems are normal your systems, right? So every system has some hard disk, right? So consider each system is having 4 TB of hard disk. If you want to process 20 TB of data, hardly I can have 5 systems in my cluster. That is enough actually. And if you want to process more data, like let's say 30 TB of data, I'll try to keep on increasing this one. Because what happens, because each system is having 4 TB of system, Siva. Now, how come it is going to solve the 20 TB of storage here? Guys, once you install this particular distributed file system software in your cluster, so I have to call this as a cluster. In the cluster, I'm going to install DFS software. That is Hadoop software. If I install this Hadoop software, now this 4 TB, 4 TB, 4 TB, whatever the memory you have, right? This entire memory, this entire cluster will act as a single system now. All these systems, our entire cluster is acting as a single system now. Now, single system is actually processing your data parallelly. Single system is actually storing your 20 terabytes of data in a cluster. That is what the concept of Hadoop actually. They are not treating this 4 TB as a separate memory. They're considering 4 TB, like let's say 1, 2, 3, 4, 5, 6 systems are there, right? Now, the overall this particular system capacity is 6 into 4, 24 TB. The capacity of this one is 24 TB. It's a single system indirectly. Now we are able to store the data also, right? Now the problem is solved. Yes, did you get my point? Is it boring?
No.
Only one guy is responding. Other people are not responding. That means it is boring.
No, it's fine.
Okay. If it is boring or not boring, I cannot do anything. I'm trying my level best to help you guys. Yeah. Okay. Okay. Now, why Hadoop is useful here for all these problems? The first point is Hadoop is scalable. Scalable means as the volume of data is increasing in your industry, in your company or in your organization, you can go ahead and increase any number of systems to your cluster, so that solves the problem of your volume. Okay, and it is economical. It is not costly, and the hardware was very cheap. Hardware is very cheap. Commodity hardware you can use. Normal systems you can use. You don't need to use the servers there. You can use the normal system. So they're very cheap, I can say. And they're efficient, of course. They're processing the data like parallelly. And that too, the data is reliable, guys. Reliable means what happens, here. I have like slide deck also for that one. I'll try to demonstrate that. At any point, okay. Now you may get it out here. Siva, you said that, okay, let's say in a cluster you have 5 nodes. Node 1, node 2, node 3, node 4, and node 5. Okay. Consider your 20 TB of data you're storing in all these systems. Let's say consider 10 systems are there here. You're storing 20 TB of data in all these systems. Okay. Now, Siva, you're using cheap hardware right here. Commodity hardware right here. Then what if something goes with this hardware? Are we going to lose our data? Are we going to lose our data? No. No. Hadoop is intelligent. Hadoop has intelligence to manage that data, that issue as well. I'll show you that one. I'll show you that. Okay, how it is intelligent, I'll show you. And that too, Hadoop is free. It's an open source. You don't need to purchase the license for that Hadoop. You don't need to purchase anything. You just need to have systems in place. That's it. Those systems will process your data with all these concepts. Okay. Now tell me the conclusion point here. Hadoop is not a big data, guys. To process your big data, huge volume of data, Hadoop is actually helping you. That's it. Hadoop is not a big data. And Hadoop is not a database. Are we storing any data here? We are processing the data with the help of MapReduce, and while processing, actually, we are using HDFS as a storage. Hadoop is not a database. Hadoop doesn't store anything. Then what is storing actually? Who is storing the data here in that case? Your HDFS is storing the data. Hadoop distributed file system is storing your data, not the actual Hadoop. Hadoop is not a database, that too. It's a processing engine, I can say. Hadoop is a platform. It's a framework, I can say. Hadoop is not a database. Okay. Shiva, when was it came into the market? Can you explain that one? So it came into the market actually in 2011 with version 1.0. In 2013, actually, Hadoop 2.0 version released. And after that, in 2017, Hadoop 3.0 released. In 2017, I learned this Hadoop at that time. When I was learning at that time, only like 3.0 came into the market. Okay, so who's that that guy actually started this Hadoop concept? And who has given the solution to the market? This guy, duck cutting. He's the guy actually. So they started this project for one of the search engine project, that is Nudge. At that time, search engines were like slowly. There were many search engines. Of course, one of the search engine, Google, was very famous at that time. But before that one, Yahoo was also there, and Nudge is also one of the like search engine, just like your Yahoo and Google. So for that Nudge project, actually, they started this Hadoop, because search engine means they have to process huge volume of data, right? And he started that Hadoop concept. Okay. And remember, guys, and this guy actually, duck cutting, he joined in Yahoo in 2006. In 2006, he used to work for for other company, and in 2006 he joined in Yahoo. Okay, and after he joined in Yahoo company, actually, he started this Hadoop like distributed system and all. And after that, actually, in 2008, actually, like Yahoo successfully tested Hadoop on 1000 node cluster to process their data. 1000 node cluster, 1000 systems in a cluster to process their data. And after that, so they in 2009, actually, Hadoop successfully processed petabytes of data less than 17 hours. In 2009, less than 17 hours in Yahoo company only. Because at that time, Yahoo was very famous than Google. Yahoo was very famous at that time. Okay. So after that, they handed over this Hadoop like concept to the Apache Software Foundation. Hey, like you guys, Apache Software Foundation is an open source company actually. They develop open source softwares, applications, I can say. These guys actually, these Yahoo guys, handed over this project, whatever they implemented in Yahoo, right? They handed over that project to the Apache company. That is the reason why they even Spark, they call it as Apache Spark. Hadoop also Apache product only. It's not Yahoo product. I mean, the concept they have given it to like these guys actually. Now these guys actually made it open source. Apache company made it open source. It's free of cost. The software is available in their website. You can still now also you can go and download that Hadoop 3.0 from their website. You can search it in Google. Now still it is evolving actually. Still some of the companies are using the MapReduce programming. And recently also I came to know that in Canada, if you want to get the job in data engineering, if you want to get the data like a job in data engineering, okay, you have to know MapReduce programming. That's what I came to know. You have to have the knowledge on the MapReduce program. I don't know why people are still expecting this language. Okay. Now these are all the like regular terminologies we are going to use, guys, from now onwards actually. Okay. Server is nothing but a system or node. Node or server, both are same here. 20 from now onwards, I'll call it as a 20 node cluster, 100 node cluster, like 25 node cluster. I used to I'll call like that. Okay. Core. You guys know what do you mean by core, right? Now even your laptops also quad like when you when you go to the shop to purchase a laptop or system, right? You'll ask them, hey, I need quad core system or octa core system. What is that core meaning actually? So indirectly, they're dividing your processors. Your processor will be divided into different parts. When you say quad core system, they'll try to divide that, not physically, I'm saying logically. Logically, they'll try to divide it into 4 parts. 1, 2, 3, 4. Now, what is the use of this 1, 2, 3, 4 blocks, Shiva, in the processor? You know, what will happen? Logically, they will try to divide the functionality of the processor into 4. Now, this core can do one work. This part can do one work. This part also can do one work. Work means some task, I can say. This part also can do some task, and this part also can do some task. All these 4 parts can do their task independently and parallelly. That is the reason why they call it as a quad core system or octa core system. Octa core system is nothing but eight blocks. The more the number of cores, the more the system speed, more the parallelism you'll get. More the parallelism, more speed, obviously. Your system might be a quad core system. Your system might be a octa core system. Okay. Next, local. So what you have to do is, ultimately, I told you, right? You have one cluster right here. So this is here you have the nodes right here. All these nodes are connected internally via some network. Let's consider I have like 4 node cluster here. All these systems are connected in a network, guys. All these systems can talk to each other here. Now, if you want to run a job, actually, how do you like log in into this cluster? You don't log in into the cluster directly. What you guys can do is, you have a local mission. You have to submit your job to this local mission. This local mission will go and interact with this cluster actually. Now onwards, I'm going to use this as a local mission. Your local mission will go and interact with your cluster. You'll not be having any access directly to the cluster. Okay, this is the place where you are submitting your program. The program will be distributed across the like systems, and all these systems work parallelly here. Okay, now hard disk. Hard disk is nothing but, you guys know, right? Storage. And RAM. This is the more important one actually. Okay. Now tell me one thing, guys, here. In the Hadoop, where do we store the data in the Hadoop system actually, in a cluster? The hard disk of each system. The hard disk of each system. Remember that one, because why I'm stressing that point is, tomorrow I'll tell you that one, why I'm stressing that point. You'll come to know the problems of the MapReduce. You'll come to the problems of the Hadoop. Now, what I'm trying to say is, Hadoop actually stores your processing data in a hardware, in a hard disk. So here also it will store, here also it will store, here also it will store, here also it will store. It stores the data in a hard disk of each and every system in a cluster. Of course, at a high level, all these systems, this entire cluster will act as a single system, because they are connected each other right here. They are connected in a network. At high level, these systems will act as a single system. Okay. Let me tell you the reliability here. This is what I was telling actually. Node 1, node 2. In a cluster, you may have any number of nodes actually. So group of nodes form actually rack. Group of nodes, we call it as a rack. Or cluster, you can call it in any way. Okay. So you can have any number of racks in a Hadoop cluster actually. Any number of racks. Group of racks actually, we together we call it as a cluster. I can say Hadoop cluster. Sorry. Hadoop cluster. Now, why I'm trying to explain that one is, you'll understand that one. One second. I told you one point, your data is fully safe in Hadoop cluster. What do you mean by that one? I told you already, whenever you wanted to process some data, backend it will try to divide that into blocks, and all those blocks will be processed parallelly. All those blocks will be processed parallelly. Let's say if I have 400 MB of data, it will try to divide that into 128 MB blocks. 128 MB, 128 MB, how much left over here? 16 MB of data. So remaining data will be processed by block D. I mean, this block will go to the system. But this block will be processed by one system. This block will be processed by another system. This block will be processed by another system. Okay, one system actually storing this data, another system is storing this data, another system is storing this data, another system is storing this data in their hard disk. Shiva, if all these systems are storing data like this, what if something goes with the system? Are we going to lose our data or what? Or something goes with the system? What will happen to this data? Are we going to lose our data or what? No. What will happen here is, what I'm trying to say is, when something failed, let's say the system got failed, then what will happen, the backend in Hadoop actually, by default, they maintain replication factor as 3. What do you mean by that replication factor? So they store this block A, whatever you have divided before you process, they don't store it in a single system. The same copy of data, they'll try to store it in another system as well. The same copy of data, they'll try to store it in another system as well. If something goes wrong with the system, still your data is available either in data node or data node 2 or data node 4. Even something goes wrong with this system also, they'll try to retrieve your data from this block. At any point of time, every block is replicated thrice. In this way, Hadoop is making sure that your data is reliable. This is what we call it as high availability. Okay. Yeah. So that is about the introduction of the Hadoop base. Now, in the next class, what I will do is, I'll try to tell you the problems of the Hadoop. Once again, I'll recap this one in that class. And after that, I'll try to discuss about the problems of the Hadoop and how your Spark is going to overcome all those problems. That's what I'm going to discuss. Then you'll understand the use of the Spark. I think it's worth to understand all these terminologies, guys, because in interview they'll ask these questions actually sometimes. See, what I was telling so far is, the conclusion point is, day by day, the volume of data is increasing like anyway. Okay. Traditional systems actually does not have capability to process the data. Then like your Hadoop came into the market with a concept of parallel processing like this. Hey, don't process in a single system. You try to process in a multiple system, that too parallelly. Okay, then how do you process the like what is that language we have to use to process your data? MapReduce programming we have to use. How do you write, in which language you write that one, MapReduce programming? In Java language you have to write it. And where do you store the data? In HDFS inside the Hadoop. Now, Hadoop has given solution to the market's problem, I can say. This is my conclusion point. Okay, yeah.